For topics 2 and 3, we're going to start talking about events involving or. Okay, let me see if I can squeeze that in here. So for this one, we're talking again about events involving or. So quite literally, what is the probability of this or that? Okay. And when we're talking about events involving or, there are two situations that can arise. We can have mutually exclusive events or non-mutually exclusive events. So topic 2, we're going to focus on mutually exclusive events. Okay. So as a definition, if it is impossible, absolutely impossible for events A and B to occur simultaneously, the events are said to be mutually exclusive. So if two things can't happen at the same time, they're mutually exclusive. It cannot simultaneously be negative 12 degrees and 500 degrees. Just can't. They're mutually exclusive. Those two things can't occur at the same time. Okay? So, a formula. We do have a formula here. The formula for or probability with mutually exclusive events, again, meaning those two events could never happen at the same time. Well, if we have events A and B that are mutually exclusive, then the probability of A or B is the probability of A plus the probability of B. Okay. Now, the cool thing about the or probabilities is it will typically, you'll see the word or. What is the probability of blah or blah? What is the probability of this or that? So you can look for the actual word or here. Okay. So let's look at a couple of examples. We've got one, two examples, then we're going to go to the non-mutually exclusive events. Okay, so example 2 says find each probability. Again, for this worksheet, until I tell you otherwise, if the directions don't specify, assume your answers need to be reduced fractions. It's generally, I don't want to say always, but it's generally going to be reduced fractions for the theoretical type stuff. When it gets to empirical, it can kind of be either or. All right, so for part A, it says if you roll a fair six-sided die, what is the probability of getting a 4 or a 5? These events are absolutely mutually exclusive. There is no side of a die that has 4 and 5 dots. You either have 4 dots or you have 5 dots. The two will never mix, okay? So we would want the probability of a 4 or a 5. And notice here, we have the actual word or, okay? So the probability of a 4 or 5 is the probability that you get a 4 plus the probability that you get a 5. Well, with a fair six-sided die, the sample space is 6. And of those 6 possible outcomes, only one of them is a 4. So 1/6. And then when you're dealing with a fair six-sided die, again, the sample size is 6 and only one of those sides is a 5. So we get the probability of a 4 plus the probability of a 5 is 1/6 plus 1/6. So we would get 2/6, or this would reduce to 1/3. So the probability of a 4 or a 5 is 1/3. Okay, let's look at a spinner. Okay, for part B, it says a spinner consists of 8 equal pieces. 4 are red. Let's do that actually in red. That might be nice. So 4 are red, 3 are black, and 1 is white. I'll do the white one in like, I don't know, blue or something. Let's do the white one in this blue color just to keep track, okay? What is the probability of the spinner landing on red or white? So here's the deal with these spinner problems, and sometimes the word problems will flat out mention this. They'll say if you land on a border between the two colors to spin again. So you're landing exclusively red, black, or white, okay? You can't land halfway between red and black, okay? You can't land halfway between white and red, okay? You either land fully red, fully black, or fully white. Again, if you land on the border, spin again, okay? So these events would absolutely be mutually exclusive, okay? So we want the probability of landing on a red or a white. So red or white. So that would be the probability of landing on red plus the probability of landing on white. Now we have 8 equal size pieces for this spinner. So the sample size is 8, okay? Now, the ways we could land on red, there are 4 red pieces on this spinner, and then there is 1 white piece on this spinner. So if we want the probability of red or white, it is going to be 4/8 plus 1/8 or 5/8. And that would be your final answer. Okay? Now, example 3 goes into the next page. All right, so example 3 again says find each probability, and I'll tell you when we want to start doing decimals, but for now, go ahead and assume that we want reduced fractions as our answer. Okay, so for part A, it says you are dealt one card from a standard 52 card deck. What is the probability of drawing a face card or a 10? Now, when you think of a deck of cards, there are cards that have faces, and then there are cards that have 10s, but there is not a card that is half face, half 10. You either get a 10 or you get a face card. There's no mixing of the two. These events are definitely mutually exclusive. So we want the probability that we get a face card or a 10. And again, you see the actual word or with these or probabilities, okay? So we want the probability of a face card plus the probability of a 10. Well, when we're dealing with a standard 52 card deck, the sample space is 52 cards. So we're going to get two fractions, both with a 52 as the denominator. For the face cards, remember, in a deck of cards, there's one face card that represents one face card for each month of the year. So there's 12 face cards, 3 for each suit. Okay. And then for the 10s, there are 4 10s in a deck. So there's a 10 of hearts, a 10 of diamonds, a 10 of spades, and a 10 of clubs. So 4 spades. No, 4 10s. Bless my heart. Whew, that was trippy. Do I need a nap maybe? Okay, so we have 12 face cards. We have 4 10s, okay? And so that means we have 16 out of 52 cards. These are both divisible by 4. So we would get 4/13, and that would be your probability. And make sure you understand these are 10s, not hearts or spades or whatever I was trying to call them a minute ago. Okay. So 12 out of 52 for the faces, 4 out of 52 for the 10s, 16 out of 52 total. That reduces to 4/13. Okay. And then finally for this video, it says for part B, you are dealt a card from a standard 52 card deck. What is the probability of being dealt a 4 or a 5? So when you're dealing with a deck of cards, you have cards that have 4s on them, and then you have completely separate cards that have 5s on them. There is no card that is half 4, half 5. There's no mixing of the two. These two events are mutually exclusive. They cannot happen simultaneously. So we want the probability of a 4 or a 5. So that means we want the probability of a 4 plus the probability of a 5. Well, out of the 52 cards in a deck, 4 of them have 4s on them. That's kind of a mouthful. And then 4 of the cards out of 52 have 5s on them. So we get 4 out of 52 plus 4 out of 52, which is 8 out of 52. Both of these are divisible by 4. And so that gives me 2/13. It is really helpful if you know that 52 is divisible by 4 and 13. Those are going to come up a lot when you're simplifying these fractions, and it can save you a little bit of time if you can do that in your head. Okay, so that is OR probabilities. When you're dealing with OR probabilities, in general, we add the two separate probabilities, and in this case, we're dealing with mutually exclusive events, events that can never occur at the same time. So you simply add the different probabilities, and that's it. Okay, in the next video, we will talk about non-mutually exclusive events.